diffraction of waves is all about how they spread out when they go through a gap or when they go around an object or an obstacle. And significant diffraction, i.e. diffraction that we can see clearly and noticeably, is only seen when the wavelength is about the same size as the gap or obstacle. So we have some diagrams here that you need to know how the waves travel through and how they diffract. And we first of all start off with a gap size, which is about the same size as the wavelength. So we should expect to see quite a bit of diffraction, quite a bit of spreading out. And so what we should see is a large spreading out of waves in a kind of circular pattern. And one thing to note, please make sure that the wave length afterwards is the same as the wavelength before. Now, excuse my drawing; they're not perfect, not brilliant, but I've tried to make the wavelength about the same size before and after. Okay, so what about when the wavelength is very small? What actually happens to the waves? So we should see something like this. Now I'm just going to complete this. It's going to spread out only a little bit, and we're going to keep the same wavelength. There we are. Oopsie. Okay. Not brilliant, but you get the idea. And so we're spreading out a tiny bit, but not very much at all. And that's, again, keeping the same wavelength afterwards as before. The wavelength is much smaller, so we don't diffract as much. What about wavelengths that go around an object? Well, here's an object, and it's about the same size as the wavelength. So we're going to see significant diffraction. And what we see is that the waves spread out after the object and quickly meet again to join up. We get a kind of dead zone, a shadow, if you like, where there's no waves. Shadow. But it quickly disappears. Now, if you have a small wavelength going around an object, we will see hardly any joining up, and that shadow will be much longer. So I'll just complete this diagram a little bit. There we are. There and there, and you can see that the shadow will continue to get smaller, but it's much longer shadow. A longer or larger shadow than when the wavelength is about the same size as the object. So that's diffraction, 4 cases, and you need to know that you only see significant spreading out diffraction when the wavelength is about the same size as the gap or the obstacle.